Annual worth is another way to assess projects, as with present worth and future worth, which we have talked about already. So annual worth is A, and a lot of times when we say annual worth, we're referring to the worth per period, and then we can calculate annually. And what I'm trying to say is it doesn't always have to be originally in years. What you have to do is you have to be careful with the information you're given and interpret it properly, because using A or using the word annual, like in annual worth, can be a little misleading. And it's a common mistake, especially when there's different types of different compounding periods. But again, we have talked in the past about how to get A, but in this case, we're just talking about how to use A to make decisions. Okay. So annual worth is an equivalent periodic series of dollar amounts that is equivalent to the cash inflows and outflows and an interest rate that is generally the MAR. The MAR being the minimum attractive rate of return. The annual worth of a project is annual equivalent revenue or savings minus the annual equivalent expenses minus its annual capital recovery amount. So that's the R, the E, and the CR. But the CR, the capital recovery, comes from things that are not given to you in annual, meaning they can be present, like present costs or benefits, future costs or benefits. So they can be, for example, the loss of value in an asset or other things. So what it is at the end of the day is that credit recovery has its own formula, and this depends on initial cost and salvage value. Initial cost tends to be at the beginning and salvage value at the very end. So it doesn't have to be that way. And by the way, this is an important note. Is if you see, this is making my outflow positive and my outflow positive and my inflow negative, even though salvage value is a good thing, it's money coming in. In this situation, it's being flipped because we're talking about CR, meaning capital recovery. It's being treated in the if I go to the previous slide, let's see, oops, oh come on, it is being subtracted, so we want to subtract a positive number. We don't want it to be a negative number. It's being treated as a cost here, and therefore it needs to reflect that with consistency here. Okay, let's do examples. A project requires an initial investment of $45,000, has a salvage value of $12,000 after 6 years, incurs annual expenses of $6,000, and provides an annual revenue of $18,000. Using a MAR of 10%, determine the annual worth of this project. So the annual worth at a MAR of 10%, remember R, our revenue, minus E, our expenses, minus our capital recovery, which is really the just getting A from, say, P or F or both. In this case, to find it, we had that $45,000, which was an initial investment, minus $12,000, which was a salvage value. This is a P and this is an F, so this is important, and it's for 6 years. So here we go, and we're going to find that number, and then we're just going to have our revenue minus our expenses minus our credit recovery, and this is what we get. Okay, I know I went a little fast, so make sure you can calculate this on your own, but I wanted to show you how to use the formula first, and now we're going to do some examples ourselves by hand. So because it's positive, it's a good investment. Now, I tend to have more examples with good investments than bad ones, but that's not always the case. Let's do another example. How much should a new graduate pay in 10 equal annual payments starting 2 years from now in order to repay a $30,000 loan he has received today? The interest rate is 6% per year. Now, this example is actually not an annual worth example. I think I put it here a long time ago so that I could have students practice this skill, which they were having trouble with. So I believe that's the origin of this problem. This is not annual worth. We're just trying to find an annual amount, but I want to make sure we do it anyway because it's good practice, and because sure, this is something students struggle with a lot. So what we have is the following. So we have a cash flow where how much should the new graduate pay in 10 equal payments starting 2 years from now? So now is he owes the 30,000. So we're gonna make this a positive because what we're saying is he received a $30,000 loan and he's going to have to pay equal amounts, and 2 years after he receives this loan, that is year 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Oh, I was missing the 11. So now the trick here is that we can't just find a and the question is asking me to find A, right? I can't just find A given P, because if I have A given P, what this is going to do is it's going to place them from period 1 to 10 instead of 2 to 11, and that's an important distinction. So the first thing I have to do is I have to find an equivalent of all of these cash flows. I want a different color. Hold on. There we go. All of these cash flows, but in period 1. So we're going to call this P at 1. So P at 1 is equal to 30,000. Oh, sorry. I'm actually sorry. I spoke too soon. What I'm going to do is I'm going to move this from here to there so that then I can use this as the P and do an A given P. Sorry if I confused you. 30,000, and then I'm going to do an F given P. So this is actually F from the point of view of P at 0. So F given P for 6% for 1 year, and this gives me 31,800. And now I can find A with P1, and then so P1 and then A given P, 6% for 10, meaning A is equal to 31,800, A given P, 6%, 10, and this is equal to 4,321.62. Whew, student loans are, you know, a little scary. But these are actually not sure what the rates are nowadays, but they're not great. So definitely look into that whenever you are starting to look into loans, if you need them for your studies. Education is important, but also try not to go into horrible debt. Anyway, neither here nor there. Okay, let's continue. Let's do an example with salvage value. So this machine costs $20,000 and has a 5% useful life. At the end of 5 years, it can be sold for $4,000 if the annual interest rate is 8%, compounded semi-annually. What is the equivalent uniform annual cost for the machine? So what I'm going to do is I'm going to change this. This is a problem that we may have seen before. I'm going to call this the MAR. So let's say that the MAR is 8%. The question is this a good investment? So again, we said that annual worth at 8% was going to be equal to my revenue minus my expenses minus my capital recovery at 8%. I don't have a revenue, but I have savings, and savings count sort of as revenue. So let's see, a machine. No. Oh, where are my savings? Never mind. So we don't have this right now. We don't have, so we don't have any of this. We're just going to calculate this part, and this part is so we have that over 5 years we have 20,000 here, an investment of 20K, and at the end of 5 years there's a salvage value of 4K. However, I want you to notice this: compounded semi-annually. So what does this mean? That I'm going to have 5 years. In 5 years I have 10 semi-annual periods, and it also means that my I, which is 8%, needs to be divided by 2 so that it's 4% per period. Okay, so now we can find this by doing the 20,000 A given P, 4%, 10 periods, minus 4,000, A given F, 4%, 10 periods, and this is 2132.8. So if I also said that this machine saved me, you know, $1,000, but it was costing me $2,000, then I could run the numbers and decide if this is a good investment. But in this case, not being given that information, I can just say that with the information that I have at hand, this is only a cost, so I would need this information to make an accurate decision. So let's add that information. Let's say that my revenues are my revenues per this is right here. What I just found was my semi-annual periods. So if semi-annually, let's say that my savings or my revenue is at 1,000, but my costs are, or my expenses are 2,000, then I can do 1,000 minus 2,000. Oh, that's obviously not going to make sense. Sorry, I meant 10,000. 10,000 minus 2,000 minus 2132.8, and this, if it's a positive number, which it is, makes us very happy. Good investment, right? Great. Okay. Also, we can have an irregular series of payments. So this one said that, for instance, this maintenance foreman of a plant, in reviewing his records, found that the large press had the following maintenance cost. So this is again a problem to just calculate equivalent uniform annual cost with a gradient, and we know how to do that. Remember that whenever you have a gradient, you have to find P first, and then you can find so first you need to use P given A or P given G and then turn it to A, or no, you could just do let's see, A would be equal to 600, and then you can do that plus a 100 A given G for 5 periods at a interest rate of 8, and that should give you the same thing. Okay, well, anyway, this video is getting a little long, so annual worth, present worth, future worth, at the end of the day, they're excellent tools and very used tools, very much used in industry to calculate whether something is a good investment or not once you're given all of the information.